The quadratic formula is considered to be the penultimate problem for algebra. All right, so it's the last thing that we covered in class, and it's also probably the most complex thing that we covered in class. So just a reminder, in order to use the quadratic formula, you need this expression to be written in standard form. So it needs to be x squared, x, and a constant, but it also has to be set equal to 0. So if this is equal to like 7 or something, you better move that sucker that way. All right, so you got to add or subtract whatever's here to get it to where you have a, b, and c equals to 0. Now, when I taught the quadratic formula to my kids, I taught it to them with a song. It was reviewed with mixed reviews. Some kids love it, some kids hate it, some kids are going to skip through the next like 10 seconds of this video. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're welcome. I can hear the clapping right now. I sure can. Oh, thank you. Thank you, sir. My husband clapped for you guys. Don't worry. All right, so we have to take our a, b, and c values and plug it in there. Now, when I taught it, I did it in 2 pieces. The first piece was where we simplify this part down here. This part under the radical is called the discriminant. And the discriminant tells you a lot of interesting things. The first thing is it tells you the number of real solutions. All right, so if you simplify this and you get a whole number here, okay, such as a positive value like 14, 37, 96. All right, so if you get a positive number underneath this radical that's not a perfect square, all right, then you will get 2 real solutions. If it's a perfect square, you're going to get 2 real rational solutions, which means that you won't have the icky yucky square root in the end, which is nice. Now, if you solve out the discriminant and you get the number 0, the square root of 0 is 0, so it doesn't matter if you add or subtract 0, nothing happens. So what happens is this whole thing goes away, and you're left with a single number. It's beautiful. Now, if you get a negative number under here, you're going to get something imaginary. Because remember, you can't take the square root of a negative number. All right, so when you have that situation and there's a negative there, you take it out in the form of an I, and then simplify the radical as you normally would. But that's more of an Algebra 2 concept. If you get a negative number under there, you go, nope, not my problem. So here we are. I have an example of a quadratic formula question. Looking at this, I see that my a value is 2. My b value is negative 10. And my c value is 3. All right. It's worth pointing out here, the equation is set equal to 0. Don't go through all this work without setting it equal to 0, okay? And I always start with just the discriminant first, all right? I don't even play around with the whole formula. I just do the part of it that says b squared minus 4ac. I'm also going to zoom in because I feel like I'm a little cramped for space. So b squared minus 4ac. That has the letter D next to it. You just can't see it. Okay, use your imagination. Okay, so now that I know b squared minus 4ac, I tend to leave some spaces. So there's my space for b, there's my space for a, and my space for c. It's really important when you're plugging these in, guys, that you plug in with parentheses. If you don't, you're going to get some weird numbers. So for example here, the negative 10 squared, if you plug that into a calculator without putting parentheses around the negative 10, it's going to spit out a negative 100. Oh, why did I say 0 for C? It's because I was talking. But you don't want it to spit out a negative 100. You want it to spit out a positive 100. Because a negative number squared is a positive number. All right, so here negative 10 times negative 10, that's what squaring is 100. And here, 4 times 2 is 8, times 3 is 24. And 100 minus 24 is 76. I'll zoom it back to normal. Now the thing is I don't plug 76 into the equation. The quadratic formula asks for the square root of the discriminant. So while I'm here at the side of the problem, I'm just going to try to take the square root of that discriminant. Take the square root of 76. Okay, that requires a factor tree to simplify. So 76 is even, so I know it's divisible by 2. I want to say it's 38, but I'm using a calculator to check myself. Because remember, if you don't check yourselves, you're going to wreck yourselves. Don't do that on your final. 38 is still even. So I go back to my calculator, and I divide 38 by 2, and I get 19. 19 is a prime number, y'all. It doesn't break up. So I have the discriminant of, the square root of the discriminant, which is the square root of 2 times 19. All right, so you take out your pair, so the 2 comes outside, but the radical doesn't have a pair. Come on, you. The radical doesn't have a pair here with the 19, so the 19 hangs out. So the square root of the discriminant is 2 root 19. That was all the work for that blue section, okay? So I'm going to take this quadratic formula where all this other stuff is and write it in there. So I have x equals negative b, okay, we'll figure that out in a second, plus or minus the 2 root 19 I just did all that work for, all over 2 times a. And again, my b was negative 10. And my a, which is blue, is a positive 2. Now I'll be honest, I'm a very lazy person. I go out of my way to not do any effort if I can. So when I write this out on my own, I know that a negative 10 would become positive. So I usually just put a positive there if I can. I just flip whatever sign b is. I also know I'm going to times by 2 in the bottom, so I just do it. I don't write this form out, I just write out this next step I'm going to write out. I'm also going to zoom in. Or fail to zoom in because my pen doesn't work great. Okay. So negative 10 is positive 10 plus or minus 2 root 19 all over 2 times 2, which is 4. Now the thing is this is a fraction, right? And anytime, well, that's actually getting worse. That's better. Anytime you have a fraction, you always want to reduce it. So the way that you reduce is you look at this term here, not the number in the radical, the number in front of the radical called the coefficient, and this number here. And you see if you could divide anything out of all 3 of those numbers. All right, so I'm thinking between 10, 2, and 4, what can I divide out? Well, they're all even, which means they're all divisible by 2. So 10 divided by 2 is 5. 2 divided by 2 is 1, so I just call that 1 root 19, which is root 19. And 4 divided by 2 is 2. And that gives me this. This is the exact solution. Okay? Because this is not a rational number, it has a square root on it, which you can't see because I'm not zoomed in, right? There we go. So because this has a radical on it, if I were to type this in the calculator, I would get a hideous answer. If I zoom in, I hate this. I can't get it to fit on my screen right. That's okay. Now, some people ask for the exact and some people ask for the approximate. So to get the approximate answer, you're going to need a calculator. All right. So I'm going to solve out this problem where your plus or minus symbol there is just a plus. And just type that in the calculator. Then I'm going to do the same thing again, but where the plus or minus symbol is, I'm going to put a minus. Now you want to be careful when you guys go to do this, okay? In a TI calculator, some of you guys go 5 plus root 19 divided by 2. The calculator reads it from left to right. And so because of that, you have to be careful and you have to use grouping symbols. Or you have to find subtotals before you divide by 2. Okay? So on this one, I got about 4.68. Oh, I should not use the laser pointer if I'm trying to write. So about 4.68. I rounded that to the nearest hundredth. All right. Now when I go to do this other one, all right, the way that I'm using it on my kind of crappy computer calculator, I'm taking the square root of 19, which is 4.3, and I'm making it negative. Then I add the 5 and get a total, which is about 0.64, and then I divide by 2. So that's where I'm getting about 0.32. So remember, every calculator works a little bit different. So you need to practice with yours before you take the final, because it could be a bear. But there it is. These are the approximate answers, the ones in red. This one's the exact answer.